All right. Hey there, physical science students. This is Mr. Barry at SCORE Academy. I'm here to explain the last custom for the physical science class here. It's on electrical circuits. And so this is custom 6, electrical circuits. Good job. You're almost at the end. You're doing great. Okay. So last one here. Standards are available here at the top, and you can click that link and check out all the standards if you are interested. And reminder, you're always going to respond at the orange text. So please make sure you're reading all the directions and responding where you need to, right? So you see some of the orange text right here. As soon as I start typing in this one, it will come in as orange as well. That helps you know where you need to respond, and it helps us see where your responses are and grade them. So part 1. We've got to do the best we can to build some circuits, all right? So you can open this circuit construction kit, and we're going to click the lab option. So I think that's important to note right away. So when you go to this, don't do the intro. We're going to do lab. So again, make sure you're reading those directions, okay? As that opens up then, we're going to follow this. I tried to show some of these images to make this pretty obvious, but we're going to do 2 things. We're going to make a series circuit here, right? We need 3 wires, 1 battery, 1 light bulb. I'm going to quickly kind of show you how to do that, but realize please that there are some directions here as well, and that you can disconnect also the wires by clicking on the connection points. And I'm going to show you that real quick, but that's what we're going to do here as we put in some of these different items to make different circuits. So to start, we're going to take our wires. I'm dragging them from the column on the left, and just trying to put them all together here in a way so you see how they connect at these certain points. The little red circles, and then I can switch it around here and move it down, and now I have a circuit there, okay? And that's what I'm looking to do to start. I can open it back up by clicking this right here, and then clicking that cut. And now I've opened it back up, and I can put something else in between here now to see if it'll make a circuit too. So on the left, again, I'm scrolling down there, and you can see the little navigation bar on the left. I'm gonna grab, let's just say, a paperclip. And I can put it and attach it as well. And then I noticed that the lines are just as long as they were before. So when I do this table down here, the bulb, I could say it's bright. It was the same brightness as it was. In some cases, the lines aren't going to be as long, and we would say then that that's dim. And if there's no lines at all coming out from around the light bulb, then we're going to say that it's off right there, okay? That should help you determine whether or not it's a conductor. Light only comes out of the light bulb if it is a conductor. From there, then, we've got a student response, so make sure that you respond to that too, and note that, that hint that's there. Part 2 is going to talk about Ohm's law, which is how we kind of do our calculations here for different circuits. There is a link here and an imagery that will help you see what that looks like. So, it's a little article. It goes through. It shows you this image, which is a big part of, kind of how all these things work together. So voltage pushes the current, and then the resistors kind of narrow down the circuit there and slow it down. That's the general idea of how all that stuff works. As you utilize these different simulations, so for part A, you'll click on the link up here at the top. For part B, you'll click on this link up at the top, okay? You'll pick the right answer from the drop-down here based on looking at that simulation. So the Ohm's law one looks like this, and it's really just showing these factors, and you can increase one or decrease it. And what it does is with the equation, I know it makes a funny noise too, but it shows you what happens to the other variable. Okay, so if I increase the resistance, you see the current, that I gets smaller, which means the current goes down. If I decrease it, this gets bigger, all right? And that's all we're looking to see right there. Looking through those will help you answer these. And then based on what you see there, you can respond to this question at the bottom. So think about moving those bars all the way up and all the way down in order to respond to those questions. It's the same idea here for resistance in a wire. You see it's going to be a similar thing. There's one more variable, which is why there's a couple more, another 2 questions here to look at. But we're doing the same idea, all right? So for resistance in a wire, I'm going to go over here and I'm going to change the resistivity and see what changes. I like this one in particular because it also kind of shows you how much is moving through here and what the resistance overall is in a wire as a current goes through it. So I can change the length of the wire, I can change the cross-sectional area, and what I want to know is how is this R changing? If it's increasing, it's getting bigger. If it's getting smaller, it's decreasing. And that's how we're going to answer all these. And then part 7, again, we want to know based on minimum and maximum values, which means we're going all the way up and all the way down, seeing what changes this the most. So what would affect the R the most, okay? So similar really overall for these two. We're just kind of analyzing the equations there. And then electrical circuit, we want to take a look at that. And I want you to consider both parts A and B as you respond right here. The last part, I'll give you some resources here. A reminder of the difference between a series and a parallel circuit first, right? So this goes through and talks about the differences between those. It shows you your diagrams that you've seen before at this point, talks about the differences in them. And then we've got this other also resource here. I know this drawing looks crazy, but don't worry. It's not something you'll have to do that's nearly that, well, cookies, yep. That's nearly that in depth, but it goes through why you have things a certain way in your home. And I feel like that's very, very relevant to you, is to know about the power that's running through your house. So this last part here is meant to be, personally relevant. And I want you to consider then in 2 to 3 sentences here, like these prompts really. Take a look at these and consider what types of circuits are in your house and why they are that way, and give me a response on that down here at the end. So I hope that's helpful. I hope that points out exactly what it is you're supposed to be doing, and good luck.